Hello, in this lecture we'll discuss about class methods and how to use it. So what you will learn basically is that in Pharo, class methods are normal virtual methods. So it means that you can send messages to classes and the method lookup will work normally, like regular objects. And most class methods are usually used to create new instances, but sometimes they can do other things, and we will see that it can be really useful. So let's have a look at this case study. So imagine that we want to parse this string. So this is a string representation of a document. So here we have a title and a list of items and maybe a paragraph there. And we want to create a parser for this piece of text. So here we have a design of this system. So we have a parser class and we have a superclass here, document item, with subclasses that represent the node elements of the text that we want to parse. And the interesting point is that in this design, each document item subclass knows if it can parse a line. So the canParse method there is implemented in all subclasses, and this is a class-side method. So it means if I give it a piece of text, it can answer a Boolean if it can parse this text or not. And then the second point is that each class knows how to create an instance of itself using this piece of text. Now, given that the parser is implemented like that, we have two methods in the parser. The document classes here that compute the collection of all classes that can parse a piece of text. So here, in this expression there, we will query the system to get all subclasses of the document item class dynamically. And then we will order these subclasses by priority. Okay, and now that we have a collection of classes, we can iterate over this collection, and using the canParse message, we can find the first one that can parse a specific line of text. So this is a really useful pattern because it means that I can easily add new subclasses and it works perfectly. And this pattern is also used in the command line interface. So let's have a look at another example. For example, here I have a command line. So here this is a Pharo virtual machine. Here I have the Pharo image, and this part of the command line is handled by the command line handler. Okay, and we have specific classes in the system that can handle those commands. And we have a lot of different commands that are supported by the system. And here this is an eval command. So this is a keyword that is there that defines the kind of command that can evaluate the expression that is right after. So it means that each classes in the system or each application in the system can introduce its own command line handler. So this is an extensible solution. And how it is done? This is exactly the same pattern. In the command line handler, we will first query the system to detect all handlers in the system. And this is done there. So it means that I will detect all subclasses and I will exclude those that are abstract. And then I will select the one that is responsible for a particular command. Okay, and how is it implemented? There is a default implementation in the command line handler class. It is responsible for arguments. I will pass the arguments and it will answer a Boolean if this class can deal with this kind of commands. And then in a subclass, here I am in the subclass, command line handler, evaluate command line handler, and I have a hook method there, self command name, that is redefined in the subclass evaluate command line handler that just return the eval. So it means that all commands that are starting with the eval keyword will be handled by this class, evaluate command line handler. And this design is completely extensible by adding new subclasses of the command line handler. So this design, as we said, is completely modular. This is extensible by construction, but there are some cons. Checking all subclasses all the time is really costly. Each time you ask a class for all its subclasses, this is a costly operation because usually all classes knows their superclass, but they don't know that their subclasses. So it means that you need to iterate over all classes of the system to get the subclasses. And then probably sometimes you don't need such a dynamic behavior. Sometimes it is useful, but sometimes this is not so important to query the system each time. So in conclusion, classes are regular objects and we can send them messages. The method lookup is exactly the same as for regular objects. It goes to the class of the receiver and it follows the inheritance chain. Pharo makes it really easy to iterate over subclasses, and it allows for really modular and extensible design as we saw. But the problem is that it is really costly. So this is something that we will address in the next lecture on registration.